Welcome to the VHDL Design and Modeling of Digital Systems course, Basic Finite-State Machine Demonstration. The basic foundation of the state machine is just a combinatorial process that feeds a sequential process. The next state is fed to the sequential process, and the output of the sequential process, which is present state, is fed back again into the combinatorial process, including the input. The clock obviously goes to the sequential process. There are two types of state machine outputs, mealy outputs and Moore outputs. This one shows the Moore output. Moore outputs are a function strictly of the current or present state. The mealy output is a function of present state and inputs. If we want both mealy and Moore outputs to be registered, this is how we would do it. Basically, the Moore output, which is sequential process, we take the next state, which would tell us what the next Moore output would be, and then outputs the Moore output. And the sequential process for the present state calculation or present state would output the mealy output. Here's an example of a state diagram. Basically, we have three states: state 0, state 1, state 2. You see from the legend at the bottom of the screen there, inside the state bubble, above the line it's what the present state is, and below the line is what the Moore output is for that present state. Whereas the input and output, as shown there, it shows what the input to go to that state would be, and also what the mealy output would be, and subsequently on the output what the state machine input would be, and also the mealy output again. Basically, if the input is 0, FSM 0, then we would transition from state 0 to state 1, from state 1 to state 2, and from state 2 to state 0. But if the FSM input is 1, then we transition from state 0 to state 2, from state 2 to state 1, and from state 1 to state 0. It also shows you the Moore outputs. If you the mealy and the Moore outputs, for it's 0 for state 0, 1 for state 1, and 2 for state 2. And the mealy output, you see it changes from 0 to 1, and from 1 to 2 when the FSM is 0, and it goes from, let's see, where it goes from 3 to 4 to 5 as it transitions from 0 to state 1 to state 2 back to state 0. Here's the entity declaration. Basically, it's clock input, and the inputs and outputs are basically defined as integers. The FSM input is an integer, and the two outputs are mealy and Moore, and they're both designed, or they're both implemented as registered outputs. The sequential process, all it does here is on a positive clock edge, we're setting present state and the mealy and more outputs to what their next values are, next state, next more output, next mealy output. You'll also notice that the internal word is used here for the signals because more output and mealy output are defined as outputs, but in the entity declaration, however, you're not going to be able to read those internally. So we create an internal version, and then in another piece of code, we basically assign the internal versions to the actual outputs. Here's the next state combinatorial process. It calculates what the next state is. It also calculates what the next mealy outputs are as well. First thing you see in the process here is that both the next state and the next mealy output are set to what they currently are. This follows the convention that your beginning of all your combinatorial processes should be doing their default signal assignment, so you don't accidentally create a transparent latch. And you see that when you're in state 0, you check to see if FSM input is 0. If it's not, you check to see if it's 1. Remember that if it's not 0 or 1, then your state diagram doesn't show that it goes anywhere. So it should stay in that state, and the FS and the mealy output should also stay in its current state. Here's the combinatorial process for calculating what the next more output would be. As I showed you before, the default assignments are made in the beginning of a combinatorial process. So we set next more output equal to internal more output, and we basically, for state 0, state 1, state 2, set the next more output to 0, 1, and 2. take a look at the simulation of the basic FSM. Basically, all we're doing here is providing a clock. We've instantiated the basic FSM module here. And we're periodically changing the FSM input from 0 to 1 to -1, and then back again. And the test bench has a test file it reads from. Let's go ahead and run it. Run simulation. And bring it out. And we see here the more output and the mealy output as we change the FSM input from 0 to 1 to -1 and back to 0 again. And the more output goes from 0 to 1 to 0 again. And the mealy output goes from 0 to 5 to 1, and so on and so forth.